remind you is that when you look at these questions, you were asked to graph all of them to look at the possible solutions. And if you did not, I need to see the graph. And when you look at the graph, what I am looking for is our general form of our equation is y equals in all of these x squared plus, and I'm going to put b. Actually, it was a c when we think of the quadratic, right? Plus the constant, okay? This, if there is no middle term, tells us that our vertex is always located at 0 and then whatever the c is, right? Does everyone remember that from the first unit, right?
Yeah.
So when we did H1, all of those. So when I look at number 9, where do I know my vertex is in number 9? 0, 7, right? 0, 7, and I know the graph is going up. And what I want to do now is plug in 1 and plug in -1 here. And if I plug in 1 and -1, I get 8, and so I can kind of see that this is how number 9 looks, right? Okay. So on my graph paper, I have the equation for number 9, and I have that. I go to number 11. And where is number 11 going to be for a vertex? Because it's 3x squared minus 12. It's going to be down at negative, where? Negative 12. So I know this is going to be down at negative 12, right? 0, negative 12 for question number 11. What do I know the shape of the graph? Is it going up or going down? Up, because x squared was positive. So now, because I had x is 0, I might try plugging in if x equals 1 and x equals 2. And when I plug in 1, what do you end up with? So 1 squared times 3 minus 12. I know you're waiting for me to do it, but what do you get? We get negative 9, right? 3 minus 12, right? 3 minus 12, we get negative 9, okay? So now we put in 2 here. 2 squared is? 4. Times 3?
6.
4 times 3?
12.
Minus 12 gives us?
0.
0, which is the solution if you would have solved this. So someone said, oh, that one is there, and this is a really narrow graph, right? And it should be because our lead coefficient was 3. Versus when I see number 13, it's going to be a much wider parabola, right? So all of these you had to graph. Now, I had someone do number 11 and say, well, Mrs. Thompson, I didn't graph it, I just solved it. Great.
Yeah.
I need the graph. You need to go back and see the graph. Because the most common mistake that I have people do when they solve number 11 this way is that they will go, oh, 3x squared equals 12, x squared equals 4, and x equals 2. And x is not equal to 2. X is equal to 2 and negative 2. There were 2 solutions. So I actually want you to do the graph, okay? So if you did not do the graph on these first ones, I need the graph. Because on the rest of it, you do not have to do the graph. So, other questions? Owen, you said you had some? No, yes?
I just don't get how you graph.
Do you understand it now? From what I just talked about? Does that make sense?
Yeah, I get it.
Okay. So there's no middle term. So we didn't have to do the middle term like we did on the quiz yesterday. Yeah.
So my question is just like, so you get the vertex from the 0 and C, and where do you get the, like, do you just like plug in other different numbers?
Well, because it's because it's on this y-axis, I'm probably, like when I go to solve like number 15, I'm going to subtract negative 5 from both sides because I need it equal to 0 in order to solve this. So x squared equals 0. All the rest of these were equal to 0 except 18. When you notice almost all these equations down here, they equal 0. And if they don't, you have to get them equal to 0 before you can solve them. So what numbers would I pick? I always pick numbers that are really close to 0. I go with 1 and negative 1. And yesterday, I think it was Kylie that asked, so I always have to make this XY table once I find that my vertex is at 0, and in this case, it was at 0 and 7. Do I need to make the whole table and fill it in? Well, I would for sure make sure you kind of know where 1 and 2 are, in that one was at 9, and once you get a couple of points, you can just graph that. But you want to pick points close to your vertex and plug them in to the equation. And you have to follow order of operations, which means you have to square before you multiply, and then you do the addition and subtraction. Yeah.
So for number 11.
Yeah.
Let's see, I got x, well,
X equal 2,
I solved the equation
got 2,
and got 2.
and negative 2, hopefully.
And I went back to the x equals 4 and graphed that.
You want to graph the original equation. Because I agree that when x squared equals 4, that is also, if we look at x squared minus 4 equals 0, if I would have this graph, and it's at negative 4, this is going to be this point and this point, and it would go at 2 and negative 2. That is also has another, it's another parabola that has a solution of 2 and negative 2. But what they wanted you to see is how thin this was, what this parabola was, because our lead coefficient was 3, versus when you do this parabola, and I am looking at negative 3, right? And I go down to negative 3, and this one came out to be a solution of 3. This is a much wider parabola. That's what they want you to see, okay? So it is important that you do those. Questions on any other solving besides the graphing? Okay. Questions on any of these when we were doing through number 49? Okay. So today you're going to have some more like the area problems. So if you would please turn, and you will be graphing again. We cannot solve the first one because it is not equal to 0. You don't have a C value of negative 15 because it's not equal to 0. So when you look at graphing, it is always y equals x squared plus c, but that is when this x squared plus c or minus c equals 0, okay? And since the first equation does not equal 0, to get it equal to 0, Jack, I'm going to do what first? Add 15. And when I add 15 on both sides, I end up with x squared equals 0. And that is beautiful to graph, right?
That is amazing.
What is yours?
Oh, that's not our. That's not what we have.
Oh, you have a different one. Ours is x squared today. Gavin, we got to start off with finding our b, right?
Yeah.
X is equal to, what is my a here? 1, b is 3, and c is
Negative 10.
negative 10. C doesn't really help us in our graph so much, but as we are looking at this, we want to look at going with x is equal to negative b over 2a. So I'm going to substitute in. So Owen, I'm going to have what for my b? For writing this one for number 1? Negative what? What's our b value?
Our b value
Right here.
negative.
So we're going to have negative 3 divided by 2 times 1. Our vertex is at negative 3 over 2, which is as a decimal how much? 1.5. Negative 1.5. So I do need to make an XY table for this parabola, right? Because I need to see where that is. Now, at negative 1.5, do we know our parabola is going up or down?
Yes.
Which way is our parabola going because of the x squared? It's going up, right? This is a 1x squared. So I am going to go over here to negative 1.5, right? Negative 1.5. And I got to figure out where my vertex is, okay? So I need to find the y point. So please, right now with your calculator, plug in x equals negative 1.5. Because right now I know this is my axis of symmetry, right? This is my axis of symmetry. This is what some of you are not writing down, negative 1.5. Use your calculator. If you don't have a calculator, grab one and plug it in.
No, negative
1.5. We put parentheses, and then it is negative down here, 1.5, okay? and we are putting our back parenthesis and we are squaring that.
My calculator.
Yeah, no, actually though,
My
when you plug that in,
calculator-
it comes in as a negative.
My calculator works exactly.
Did you put it in, this in like this? It should come out positive. We're gonna keep going, we're gonna put the whole equation.
No, I
Plus-
didn't, because I already did it. It's completely fine.
Just plus 3, and you're taking it times, and this time we are looking at times negative 1.5. And then we are adding a minus, subtract 10.
Hey, look at that. It's like this.
So, those of you with calculator error, my question would be,
You have to put parentheses.
hello? Hello? We've only said this for how long? Oh my gosh, negative 12.25. So, I don't need you, Gavin, to graph the whole thing. But what I want you to look at is this is gonna be way down here, right? And negative, and maybe you set your scale, so negative 1.5, negative 12.25.
I'm just gonna go back to
And if I am looking at solving this, the question just says, will it have no solution? Or will it have a real number solution? So solve the equation graphing related function. So what I want you to do for questions 1, 2, and 3, I just want you to tell me, is it gonna have one solution, or is it gonna have no solution, or is it gonna have 2 real number solutions? So this answer should have 2 solutions, right? Why do I know it's gonna have 2 solutions? My parabola is going up, right? And I could plug in the numbers. I just need you to tell me for questions 1, 2, and 3 that it either has 2 solutions, 1 solution, because it's on the vertex, right on the x-axis, or no solution. I want you to graph those 3. That's it. Then the rest of the worksheet, I want you to take a look down at, like when we're solving these algebraically. You need to always get the variable by itself. If the variable equals a negative number, variable squared equals a negative number, our answer would
No
be
solution.
no solution. If the variable squared equals a positive, you have to have 2 numbers, okay? I want you to look right now at the area questions, number 16. You got circle is 17, and then you have area of a square. So in your workbook, which one of these 3 would you like me to take a look at?
the hard one.
16. Well, that's
So there's area of a square, there's area of a circle, and area of a square.
19.
The radius of a
Circle.
circle,
Circle.
actually.
19, all the above.
I hate circles.
Radius,
Yeah.
So-
Let's do the circle one.
Circle.
Yes.
Formula for area of a circle. Start with that, please. Area equals
2 pi r squared.
Yeah.
Wait,
Yeah.
radius squared
Yeah. Yeah.
times pi.
Where did I get the 2 pi?
That's the circumference.
Oh.
So area equals radius squared pi, and I don't care if you write that as area equals pi times radius squared. So
I don't know how much.
we want to put in 100 for what? For the area. 100 is equal to, and it says, round to the nearest 10. So we're going to have area equals pi radius squared. How do I get radius squared by itself? Divide by pi.
So we're dividing by pi or 2?
I would divide by pi on the calculator. Now, right now, you have this for an answer. Radius squared equals 100 divided by pi. What do you need to do? Oh, if we are looking at this, what do we need to do to find our answer? We have to take the of 100 divided by pi. And when you do that, are we going to have 2 answers if we're talking about later?
Pi isn't that like irrational? So
Pi is irrational, but you are taking, if you want to think of it, when you put it in your calculator, you might get second, right? And get the square root. So right away I get my square root on my calculator, and then I'm going to put 100 divided by, and then I'm going to use the pi button.
Second and then the division, I'm pretty sure. No, second and then the carrot key.
Yeah, there it is.
not divided by square.
Okay, and now I hit enter. 5.6.
5.6.
They asked us to round to the nearest 10, so we're gonna go to 5.6.
You gotta like your calculator, do you?
5.6, and in this case, we would say inches. Okay? So these are not hard questions.
That was a lot of work.
Okay?
I don't like circles. How do you square?
19, very similar. 20. And then the last questions. Remember for 24 to 29 when you're doing this, listen up ladies, when you are doing 24 to 29, you want to make sure you are always trying to get your x squared or z squared or whatever equal by itself. So when you're doing these, you definitely want your calculator. They're asking you, what would this value of n have to be to get a solution of 24 or negative 24? So you might want to think about, they're asking what n has to be in that problem. So take a look at that. I'll help you as you're working.